Okay, my name is Jens Müller. I'm a PhD student at the Chair for Network and Data Security at the University of Bochum. And this is joint work, our current research on printer security by various bright guys of the University of Bochum. Okay, so why would anyone want to try to hack our printers? Well, printers are pretty much everywhere. They're in every office, every business, every home, and every university and so on. And it's pretty easy to actually access the sensitive information that is stored on printers or that goes through printers. So for example, you've got a high security network, and then in the end you may print the data, and the printer may be the weakest link in your IT security chain. And today I'm going to show you how incredibly easy it is to access this sensitive data, sensitive print jobs, based on vulnerabilities that are present in almost any laser printer since 30 years. Okay, clearly our printers have evolved. 30 years ago we had actually simple mechanical devices that did nothing but print. And today you cannot actually buy a printer without buying a small computer with full TCPIP stack and advanced operating system, additional functionalities such as fax and scanning and so on. But the languages actually haven't changed that much. You will see that today, that are used to actually print. Maybe the only thing that hasn't changed in 30 years is that whenever I'm in a hurry and I want to print something, even my modern device tends to produce a paper jam just like 30 years ago. Okay, you may argue printers, well, come on, that's boring. It's just another thing in our Internet of Things. What's so special about printers? And in addition to all the generic security problems that we have with the IoT and embedded devices, we had an IoT talk here before, there's something special about printers. For example, you can access the printer's file system through ordinary print jobs. You can access the printer's memory through ordinary print jobs. So even firmware update on printers is installed as a document that is printed. So you have administrative functionality and printing over the same channel, which is basically data and code over the same channel, which in IT is really never ever a good idea. Okay, what did we do? We performed the systematization of printer attacks and evaluated them on 20 printer models of different manufacturers and wrote some Python tool which you can use to hack your own printers. And we adapted the attacks to some areas beyond printers. So here's an overview of today's talk. First, I'm going to give you some basic background information on printing technology so you can better understand the attacks to follow. Then I'm going to give you an evaluation on the attacks using our Python tool, Brad, and I'm going to show you how to use those attacks on websites, for example. And I'm going to show how you can somehow protect your printer against hackers. Okay, let's start with some background info. What does it actually mean to print? Basically, it means two things. Forget everything about printer drivers. It's always the same. You first need to choose a printing channel, like a USB cable or network printing protocols. And then you need to choose a language that is used for printing, so a language that is directly understood by your printer, like PostScript and so on. And what your print driver actually does is it simply translates the document that you want to print into a language that is directly understood by your printer, like PostScript, for example. And there are not that many languages out there. Basically, PGL and PostScript. So what do we attack when we talk of printers? What can we attack? There's some kind of mechanical printing unit. We don't care about that one. There are PGL interpreters, so the language interpreters, the interpreters for the PostScript language, and there may be further interpreters for direct PDF printing, and so on. And when you print a document, you can just send PostScript data to the USB port of the printer, and it's put to paper by the printing unit. Pretty simple. And there are other possibilities, like using port 9100, which we call raw network printing, which is what most printer drivers actually do. They just send raw data to port 9100 of the printer, and it's directly executed by the language interpreters. And there are other protocols like the Internet Printing Protocol, Line Printer Daemon, which some of you may know from the Unix world, or server message block, which is known as printer shares in the Windows world. The important takeaway here is that the attacks that I'm going to present, they're independent actually of the channel that is used to access your printer. So if you access the interpreters like the PGL or the PostScript interpreter, you're independent of the channel. Whenever you can print, you can attack the device. That's the takeaway here. Okay, let me give some basic background info on PGL and PostScript. PGL is the printed job language. It was invented by HP in the early 90s, and it simply manages some basic settings like setting the paper size to A4, setting the number of copies, and so on. But there's some more with that language that is supported by almost every laser printer. Like, for example, you can do long-term settings, which is interesting. And you can also access the printer's file system through that language, which is part of the standard of that language, which is pretty cool. The other language of interest is PostScript. PostScript was invented by Adobe in the early 80s, so really, really old. It was designed for laser printers, actually, and not as a format for document exchange, which is used sometimes today. So if you print a PDF document nowadays, usually still, even today, the document is translated to PostScript, for example, and sent to the printer. Okay, the important takeaway here is that PostScript, that language that all your printers support, is not a simple page description language or a markup language like, say, HTML. PostScript is actually a Turing-complete programming language. So from the viewpoint of theoretical computer science, we know that Turing completeness means every possible program, every possible algorithm can be written in that language and is executed on the printer. Let me come to some attacks. We are in academia, so first I need to define attacker models. So our first attacker model is the attacker with physical access to the device. It's really a strong attacker model. But ask yourself, is your university department's copy room really always locked? If a student wants to steal the exam print shops, for example, that's pretty easy, right? To physically go to the copy room, infect the device through USB stick, for example, with PostScript malware, and come back later that day and get all the exams that were printed. So the next attacker model is an attacker who has got direct TCPIP access to the device. Again, you may ask, well, who would connect his printer to the internet? Well, lots of people do. These are current numbers from Shodan. You all know Shodan probably, a search engine for devices. And Shodan currently lists about 34,000 devices out there as printers. How would the attacker access the device? The attacker would use the internet to connect to port 9100 of the network printer, which is, as said, supported by almost every network printer out there. And the attacker also got a bidirectional channel to the device, so she can also directly leak and extract data. If there is some kind of firewall, of course, think in other terms of attacker models like an insider who wants to read the payroll print jobs of the department manager, or maybe a wireless attacker because the printer supports Wi-Fi. And our weakest attacker model is the web attacker. That's pretty interesting because it's basically just a website that is visited by someone within the same local area network than the printer, like, for example, an employee. And we can actually send, for example, malicious PostScript code through JavaScript to the employee's web browser, and therefore, again, perform all the attacks which are now following. Okay, we categorize the attacks on printers into 4 classes. Denial of service attacks, bypassing protection mechanisms, manipulating other users' print jobs, and information disclosure attacks. Just to get a bit more practical, let me give you a simple example for each type of attack. I mean, what always works is sending this single line of code to every laser printer, which is just tells the printer to do nothing and to do this forever, because as said, PostScript is a programming language, and yeah, you can also easily construct infinite loops with that language. Fair enough. Now think of maybe an administrator who did his job really well, and he secured everything, even the printers are password protected. And our attacker, she wants to change some settings, whatever, but she doesn't have the password, right? Well, if you're physically close to the device, you can just press some buttons and reset the device to factory defaults. That always works, but that's boring, kind of. But maybe you can also do it through the network. For example, on HP printers, you can send this line of PGL code within a print job, which tells the printer to reset itself to factory defaults and wipe away all passwords. And other vendors may have implemented similar features. Okay. Oh, now it gets a bit more funny, I hope. Manipulating other users' print jobs, one of my favorites. Well, as said, PostScript is a programming language, and you have got about 400 language functions called operators in PostScript. And one of those functions is the PostScript operator, the show page operator. And it's contained in every document in every page that is going to be printed, and it tells the printer to actually put that page on paper. And one of the cool features of the PostScript language is that you can override the language itself with only PostScript. So what you can do is you can override, for example, the show page operator, and then tell the printer to draw a smiley on all subsequent print jobs by other users. So let's give this some practical try. As said, I hope this works. So this is Mr. Printer here. So now I'm printing, you all know and you all hate that document probably. The Einkommens, at least if you, maybe you get money back, then it's cool. So I'm printing the Einkommenssteuererklärung, and I hope it works. And just to show you that I haven't manipulated everything on yeah, okay, it takes a while. So it processes the PostScript code because I use a PostScript-based printer driver, which is pretty much standard, and it's really just the document you all know. Okay, so now I connect to port 9100 using our tool, the printer exploitation toolkit, and as you can see, I've got a direct feedback to the device. I can, for example, list files on the device and whatnot, and now I want to manipulate print jobs, like, for example, overlay, let's say overlay that smiley. Okay, and now I've got infected the printer with PostScript malware. I'm printing that document again, and what now happens is that the document is just normally processed, but when the printer comes to the show page operator, our malicious code is called, and a smiley should be drawn on the document once it is printed, which is a bit slow. Ah, here it comes. Okay, here's the original document, and here's the smiley. So, and I haven't manipulated everything here. All the manipulation is done directly within code in the printer. And now, okay, you say, okay, that's just some fun, but think in terms of a programming language, you cannot only kind of put smileys, you could also, for example, introduce misspellings into the print jobs of a certain user that you don't like, or do whatever. Okay, and there's even more. The last class of attacks is information disclosure attacks. On some devices, you can access the printer's memory to ordinary print jobs. Sometimes you can access the file system, which is, as I said, part of the standard of PostScript and PGL. And with this very same technique to put smileys on print jobs, you can also capture whole print jobs, all subsequent print jobs. There are some problems like where to store them. If you've got some hard disk on a printer, you can access the hard disk and store them there. Else, you need to store them in memory as PostScript variables, which is a bit harder, but it also works because today the RAM, the memory is that much, so you can store about 100 of print jobs on the device. Okay, so let me come to an evaluation of the attacks. One problem was limited funding and academic environment and how to get enough test printers. How would you do that? Well, what we did in the end, we wrote a lot of emails and knocked a lot of doors at the university to ask the administrators if they wouldn't get us some printers for science. And that worked pretty well in the end. We got typical printers that are used in a university environment, I'd say. Okay, and we tested them for the attacks, and on the left side you can see the manufacturer, and then you can see the denial of service class of attacks, like for example the infinite loop. That one always works, that's pretty easy. But there are other possibilities to cause denial of service attacks. I'm not going into detail here. Maybe that one is interesting. On 8 devices, we were able to cause physical damage to the printer, to print jobs only, by exhausting the NVRAM's capability of accepting new values, because you can force the printer to store like the long-term value for a number of copies, and you can also do this 100 or 1,000,000 times, and the NVRAM of embedded devices cannot accept infinite number of write cycles. So sooner or later, you cannot accept new values anymore. And then you cannot really use the device anymore. Okay, bypassing protection mechanisms also worked on about half of the devices, like resetting the device to factory defaults on most HP devices, even through ordinary print jobs. Putting smileys or replacing text on other users' printouts also works very often. Accessing the memory, not that often. File system access, only on 2 devices we could access the whole. It was some embedded Linux where you could really access etc passwd and so on. The others had only certain directories that could be accessed. But even there was often sensitive information like, for example, passwords, not only for the printer itself, but also if you integrated the printer into a company's network, you could use scan to FTP, scan to some Windows domain, IPsec pre-shared keys were on the device, the credentials for Wi-Fi pre-shared keys, and so on. So if the device is integrated into a company's network and the passwords are stored on the device, you may get them as an attacker, and therefore use the printer to escalate into the company's network. Okay, capturing print jobs also works on most of the devices through PostScript, and other attacks too. I'm not going into detail. You can just see that it's kind of not just a certain vendor or manufacturer. It's like all of them are more or less vulnerable, because we are attacking the standards. Okay, just let me shortly explain the tool you just saw. It's free software available on GitHub. And what can you do with our tool, with Spread? You don't have to speak PostScript or PGL yourself. You just connect to a printer through USB cable or through port 9100 to a network printer. You just type ls, and it's translated in PostScript mode to some PostScript command. There's some PostScript response, which lists the directory, and you just get the result of ls in a user-friendly manner. And the same for PGL. So it's just everything that you could do manually, you can very easily do with Brad and perform the attacks very easily without having to learn a new programming language. Okay, here are some commands for file system access. You may know them from, I don't know, Unix or some command line FTP client, but there's a lot more. We have implemented all the attacks in the Brad tool. Okay, are you interested in attacking cloud printing? Yeah? Oh, okay. Okay, what is cloud printing? For some reason, everything moves to the cloud. I never got that, but that's what happened. Okay, we heard now in the first talk that everything, that the cloud will also vanish sooner or later. I don't know. At the moment, the trend in printing is also cloud printing for whatever reason. So whenever you send a document, you do not just send it directly, send it to the cloud, and then the cloud sends it to the printer. Okay. You can do that. And one way to do it, actually the default way to do it, for example, on Android devices is using Google Cloud Print. So you can use this to perform attacks against the printer. For example, if you get access to some Android device or through some Google account, you can, of course, just send PostScript to that printer. You've got just yet another way to attack the device because you can attack the device through the cloud also. Okay, fair enough. But what is maybe more interesting is that you can sometimes also attack the cloud directly. So you could register a printer that says, oh, well, I don't speak PostScript. I'm a PDF-only printer. I only accept PDFs, for example. And if you do that, you can send a PostScript file. It's interpreted to PDF by the Google Cloud and sent to the printer, right? But converting a PostScript document is something you cannot do without actually interpreting, without executing a Turing-complete language in the cloud on the Google server. Actually, that wasn't really that much of a problem because the Google guys, of course, they're pretty bright and all their interpreters run in sandboxes, and we found some way to do stat system calls out of their sandbox, but that was really it, so really limited attention. Still, we got some bounty for that one. Okay, now maybe we thought, can we escalate that to the web? And we're currently actually working on that. We thought, what about websites that convert, again, PostScript to PDF? There are not that many websites out there. But most of those that we found were vulnerable, from information leakage, listing files, listing file contents, to sometimes code execution through PostScript, or command execution. But there were a lot of more sites, like, for example, image conversion sites in general are often vulnerable to that kind of attacks because they use image magic in the background, so a framework that also accepts PostScript, even if you just want to upload some other file type. Or maybe your website has thumbnail previews. So users can upload photos, and then again you resize the file, and then again you may be vulnerable to PostScript execution. Actually, we tested the top 100 image conversion websites on the web, and 48 of them were vulnerable to that one. So it's a really bright, a really broad issue. Yeah, it also works on. I couldn't test it actually on the HackDo portal because I wasn't able to finish the registration to upload a profile image. Maybe somebody wants to try that out. But other websites are vulnerable. So, for example, Dropbox lets you upload EPS files. What is EPS? EPS is just plain PostScript in the end. It's a vector image file format that contains PostScript. And what you can see here is the dynamic output of PostScript code that forces a directory listing on the Dropbox server. And there are a lot of other high-grade services that are vulnerable to things like that. In this case, I'm allowed to show it because Dropbox totally sandboxes each process because they already know never trust any program that converts anything because sooner or later there will be vulnerabilities. So it's only a directory listing of some container or sandbox, no real damage in this case. Okay, so what can you do to protect yourself from such attacks? Actually, that's pretty hard because we are mostly attacking the standards that are used for printing itself. So, for example, to capture print jobs, we are only using commands of the PostScript language that is required for printing itself. So in the long term, maybe we should get rid of some 30-year-old standards and use other more secure printer languages. Until then, we need to find other solutions. What you can at least do is never ever connect your printer directly to the internet. Okay, that's really an easy one, but there was an incident in February, maybe you got that one, some gray attacker printed ASCII art on 160,000 devices around the world, especially on universities. Our university also got printouts, and I bet, I don't know, maybe the TU Dortmund and the FH, did you know anything? Because mostly the university networks are designed as open, and many devices have a public IP address, so it's still pretty easy sometimes to access those devices directly from the internet. So make sure to protect against such attacks on the IP level. What else can you do? Teach your employees to always keep the copy room locked to make it not too easy for physical attackers, for students that want to steal the exams or whoever. Administrators should actually think about sandboxing their printers and maybe all their IoT devices they do not trust into some separate virtual LAN, and in the case of printers, it should only be accessible by a hardened print server, which makes things really secure because no real harm can be done. Even if the printer would be infected with malware, it couldn't get outside again. But that's currently the only countermeasure, but it costs a lot because you need to build another infrastructure for your printers and other devices. In the long term, of course, it's up to printer vendors to get rid of some insecure standards and replace some proprietary PGL and maybe PostScript. And actually, browser vendors can do something. They can just simply block port 9100, which they already do for Telnet, FTP, and very other ports that are blocked through HTTP requests. If they do that, they could prevent a malicious website, even if it's not their fault. They could prevent a malicious website to access your printer. Okay, in the long term, of course, it's up to the to the printer vendors to make secure devices. Okay, let me come to an end. We performed the systematic analysis of printers and their standards, and we found both actually PostScript and PGL to be pretty much insecure, and we're able to apply the attacks and currently working on this to other areas like to various websites. In the long term, we want to do this for fax devices, maybe have a deeper look at 3D printing or at firmware updates, because as said, all vendors do it like that. They install firmware updates through documents that are printed. So that may be insecure. Okay, guys, thanks for your attention. The tool I showed is open source software on GitHub. And if you're interested in printer hacking, we've set up a wiki where all the attacks are explained in detail. Okay, guys, then thanks again.